Hey, what's up? It's your old pal, Mr. Cook. We're going to be going through 2.2 synthetic division. Now, synthetic division, by contrast to long division, well, actually just comparing them, it's a much easier process. It's less writing for sure, but it still gets the same job done. We can still get the exact same answers that we did over here. So, I mean, if you want a little bit of extra practice with your synthetic division, you could always just go back and divide these exact same things out and get the same exact answers for all of these if you wanted to. So synthetic division works like this. We basically concentrate on the coefficients, and we do the same exact steps that we do over here, but in a much simplified way, like less writing basically. So some of the same rules apply. Like if you're missing a coefficient for one of the terms, you still need to have a placeholder coefficient for it. We'll see that. Looks like in number 9 we could see that because we have a constant value that's missing, and also number 11 on the opposite side. So let's go through a couple of these just to kind of work through the process once, and then just kind of repeat the same thing over and over again, with our answers. So the only thing that's required is that you know how to multiply and add. And that's pretty much it. Sometimes you have to add and multiply fractions. Big deal. You've got your calculator that can do all that stuff for you. All right, so this is how we set up the synthetic division pattern, okay? You draw a little corner right here. This is where your divisor is going to go, so it's going to be part of this right over here, okay? Next, what you do is you draw a big old line down the middle right here, because this is going to separate your division from your quotient, the number that you get when you divide everything out. And then up here next to this little corner where you're going to have your divisor is going to be the coefficients on every single term in your polynomial, even the ones that are missing, like the missing terms. Like if there was a square missing or a to the first power missing, we put a 0 there. So here's what we're going to do. X to the fourth power has a lead coefficient of 1, so 1 is the first number that we put here for synthetic division. Next, x to the third power has a 9, so we put positive 9 right there. X squared has an 8, so we put 8 right there. X to the first power has a negative 31, so we put negative 31 right there. And our constant value is going to be just a negative 3. Where you have your constant value, what you're going to do is put a box below it. This is going to house your remainder. Okay, so the remainder is going to go over here. All right, so here's how the algorithm goes. First off, your lead coefficient is going to drop straight down, so it's always going to be the exact same number here and here every single time. So we need to multiply this number and every single number that we're going to get as a result by this divisor right over here. Let's figure out what that's going to be. Here's how you get the number that's in the corner over here. You start by taking the polynomial that you're dividing and you set it equal to 0, and then solve for the x value. So if I want to solve for the x value, just subtract 3 from both sides. So x is equal to negative 3. This is the factor that we're going to check. So we put that into the corner over here, negative 3. All right, so here's how the algorithm goes. Now that we've set up our synthetic division table, if you will, here's how the pattern goes. You take this number and you multiply it times this number. So the numbers that are down here are all going to multiply by negative 3. So 1 times negative 3 is negative 3, so negative 3 goes right here. And then I add these numbers straight down. So 9 minus 3 gives me a positive 6. Next, I take 6 and I multiply it by negative 3. 6 times negative 3 is negative 18. Then I add these numbers straight down. 8 minus 18 is negative 10. So I multiply negative 10 times negative 3. See, we're always just multiplying these numbers by negative 3. Negative 10 times negative 3 is a positive 30, because a negative times a negative is a positive. And 30 minus 31 is negative 1. So we have negative 1 times negative 3, which is a positive 3, because again, a negative times a negative is a positive, which means that we have a remainder of 0. We actually saw a remainder of 0 in the long division stuff as well. When we had number 19, when we divided it all out, we ended up with a remainder of 0. So that means that we said that it was a factor, and also we just left the polynomial alone, without any remainder values like these ones had. So it's going to be a similar situation here. We're going to get a polynomial for our answer with 0 remainder. And here's how you get the polynomial. These are the coefficients of your polynomial. So the coefficients start on the right-hand side. This is going to be kind of weird, okay? So always start on the right-hand side, right outside of your remainder box. This is going to be your first constant value, so that's going to be a -1, exactly as it's written, -1. The next number over is going to be your x, and then this is going to be your x squared, your x to the third. If there was another number over here, x to the fourth, x to the fifth, and so on. So we just leave those coefficients in front of our x's and our x squareds and all that stuff. So this is going to be -10x. So we have a -10x. We have a +6x squared, so 6x squared. And we have a +1 x to the third power. So those are the coefficients, 1, 6, -10, and then -1 for our polynomial. So this is our finished polynomial because it doesn't have any remainder. We don't have to add anything on to the very end there. All right, so that's the algorithm. I'm going to go a little bit faster. I hope you don't mind. But you know, these problems really don't take much time if you just stick to this pattern. So we're going to go through it a bunch of times. Rewind stuff, you know, replay the whole video if you need, but it's just the same pattern over and over again. So it really helps to practice along with me. All right, so we do the corner. That's where our divisor is going to go. Then we go ahead and put the coefficients for all of these. So we have 1k to the third, 1k to the second, -5k to the first power, and then a +28 as our constant value. We draw our line underneath those. We draw a box under the constant value, 28, and then we draw an arrow straight down because that 1 is going to be the exact same number. The number that goes in the corner here we find from the polynomial that we're dividing out. So k plus 4 equals 0. We set it equal to 0 and solve for k, so k will be equal to -4. So we plug -4 into the corner, and we start the algorithm to get to our polynomial. So we take 1 and multiply by -4. That's -4. 1 minus 4 is -3. -3 times -4 is a +12. 12 minus 5 is a +7. 7 times -4 is a -28. And 28 minus 28 gives us another remainder of 0. So all you need to do here is, once you have your coefficients, so you need to identify what the coefficients of. The first number outside of the remainder is the constant, and then you have the x, and then the x squared. So we've got 1x squared minus 3x plus 7. And there's no remainder, so that is going to be our polynomial. That's our quotient. All right, number 5, same thing. It looks like we're going up a power, so now we're up to the fourth power. It looks like actually we already had a fourth power, the first one, but so we're returning back to that. So we draw the little corner there, and then we put the coefficients. So 5, -10, -2, +17, -3, and just make sure you haven't skipped a power to the fourth, to the third, to the second, to the first, and then constant. All right, then we draw the line, put the box underneath the constant value, drop down the first coefficient, 5, and then we figure out what's going to go in the corner there. So if it's x minus 1 equals 0, that means that x will be equal to 1, so 1 goes right there. So this will be pretty easy. 5 times 1 is 5. 5 minus 10 is -5. -5 times 1 is -5. -5 and -2 makes a -7. -7 times 1 is -7. 17 minus 7 is 10. 10 times 1 is 10. And then 10 minus 3 is a +7. All right, so now we do have a remainder, so let's see how that fits into the whole thing. So here are our coefficients. The first number outside of the remainder is the constant, and then we go up x, x squared, x to the third. So writing out our polynomial, we've got 5x to the third minus 5x to the second minus 7x plus 10, or constant. And then our remainder is 7, so it's just going to be a plus 7 over whatever we divided by. So that's x minus 1. So just like how we wrote out the problem back in long division, when we had a remainder, it just gets divided by whatever we're dividing into the polynomial. All right, so that's our polynomial. That's our quotient that we get by dividing. Now we're moving on to another one here. Let's see. So we've got n to the fourth, third, second, first, and 0. So everything's accounted for here. So let's just go ahead and set it up. Corner, and then we've got the coefficients: 1 n to the fifth, 7 n to the fourth, 4 n to the third, -2n squared, 51n, and then -46 for our constant. So since that's our constant, we put a box underneath it. That's going to be our remainder. We drop down the first coefficient always, and now we got to figure out what goes in the corner here. So we do n plus 6 equals 0. Subtract 6 from both sides, n equals negative 6. So negative 6 is going to be the one in the corner, and that's what we're going to keep multiplying numbers by to get the middle numbers here. So 6 times negative 1 is negative 6. 7 minus 6 is 1. 1 times negative 6 is negative 6 again. 4 minus 6 is negative 2. Negative 2 times negative 6 is a positive 12. 12 minus 2 is 10. 10 times negative 6 is negative 60. 51 minus 60 is negative 9. Negative 9 times negative 6 is a positive 54. And 54 minus 46 is going to be a positive 8. So 8's our remainder. So here's our coefficients. The first number outside of the remainder box is constant, and then x squared, x to the third, x to the fourth, and we write down our polynomial. So we've got 1x to the fourth power plus 1x to the third power minus 2x to the second power plus 10x minus 9, and then plus our remainder, which is 8, over our divisor, which was n plus 6. So here is our polynomial. All right, so that's number 7. Now we'll do number 9. So let's see, same thing as before, but there's something kind of weird with this one, and we'll get to that in a second. So the coefficients: 5x to the fourth, 10x to the third, negative 20x to the second, negative 40x, and then we don't have a constant, so we're going to put a 0 right there. So that seems kind of weird, but since we don't have a constant, we need to keep its place in there as a placeholder. So it's just going to be 0. If there were any other missing terms, we put 0 in their place as well, because their place needs to be there to maintain the order of the synthetic division algorithm. All right, so we've got 0s are constants, so that's where we're going to put our little box there. And then let's figure out what we're going to put in the corner. So 5x plus 10. So wait a minute. We even have something else that's kind of a little bit different in that we have a 5 in front of our x value that we're dividing, and none of these have had coefficients in front of them. So there's actually going to be something that's kind of a little bit weird that we need to do at the very end, and it's going to involve this 5 right here. Okay, so we'll talk about that when we get to it. But you do the same steps that you've been doing. So 5x plus 10 equals 0. Solve for x. So we're going to subtract 10. 5x equals negative 10. Divide by 5. X is equal to negative 2. So negative 2 is the number that we're going to put up here in the corner. So we drop down the 5. 5 times negative 2 is a negative 10. 10 minus 10 is 0. 0 times negative 2 is 0. Negative 20 plus 0 is negative 20. Negative 20 times negative 2 is a positive 40. 40 minus 40 is 0. 0 times negative 2 is 0, and 0 plus 0 is 0. So we have a remainder of 0 still. And just as we've done before, this is our constant, this is our x, this is our x squared, and this is our x to the third. So our polynomial looks something like this so far. 5x to the third, and then no x squared, so we can just leave that out. And then we have negative 20x, and then no constant value, so we can leave that one out as well. So here's the weird part of it. Whenever you have a lead coefficient on your x value, this is going to seem kind of strange, but what you need to do is then divide everything by that lead coefficient 5. So it distributes in, so that means that we're going to divide the 5 out here and divide the 5 out here. So 5 divided by 5 is 1, so we have 1x to the third. And then negative 20 divided by 5 is a negative 4, so negative 4x. And this is our finished polynomial quotient. So that's pretty crazy, right? So it's just another rule that you got to watch out for. So if you need to on your homework or wherever you see it, so like number 10, for example, is going to have that same thing. Just put a big star next to it or an asterisk or whatever, so that hey, don't forget about that 5 at the very end that you need to divide out. Okay? Because it's going to be the same step every single time that you see that. All right, now for number 11. So number 11 is just back to the same stuff that we've done before. And it doesn't look like it's the same stuff, but this is just a different way to write it out. It actually is. What this is saying is that we're taking this polynomial, 8n to the fourth plus 53n to the third plus 15n plus 9, and we're dividing it by n plus 7. So in other words, we're just dividing it by n plus 7. That's just another way to write it. Okay, so let's write it out that way so it's more familiar, because it's the same steps that we've just done. So we put the corner there. Our coefficients are 8 for n to the fourth, 53 for n to the third. There's no n squared, so we put a 0 there, and then 15 n to the first, and then 9 for our constant. Since 9 is our constant, we put our remainder box underneath that. We drop down the first coefficient, 8. And then also, since we have n plus 7, we got to solve for what's in the corner there. So n plus 7 equals 0. And then n is equal to negative 7. So negative 7 goes here. All right, so 8 times negative 7, that's negative 56. 53 minus 56 is negative 3. Negative 3 times negative 7 is a positive 21. 0 plus 21 is 21. 21 times negative 7, oh geez. Let's use a calculator to get that one out. Let's see here. 21 times negative 7, that's negative 147. What? Okay, well this is just going to be a really big number. So negative 147 plus 15, let's see what that is. So plus 15, negative 132. And negative 132 times negative 7, oh my gosh, so times negative 7, that would give me 924, yikes. And then 924 plus 9 is going to be, I should have made a bigger remainder box. Okay, there we go. That's bigger. So 924 plus 9, that's going to be 933. Yikes, that's a big remainder. But, you know, the numbers are what they are, so I don't think I made any mistakes. So you can just, you know, write up your coefficients and all that stuff as they are. So there's their constant, there's your x squared, and your x to the third. So we have 8x to the third power minus 3x squared plus 21x minus 132, and then plus our remainder, which is 933 over the divisor n plus 7. There is our quotient polynomial, and we are all done with that one. Okay, so that's all of our synthetic division stuff. I'll do number 13 and number 15 on a separate video. It's not that it takes much longer, but I just want to kind of let you guys kind of work on some of the synthetic division stuff. Maybe practice some of these even numbered problems. All right, so that's about it. Have fun doing some synthetic division, right? Because it's pretty fun. It's a blast. Just admit it. You're having fun. Yes, you are. You're having fun.